In this tutorial, we will add the temperature behavior to our Mach-Zehnder interferometer. We will do this by defining a variable for the temperature of the chip, adding a small change in the effective index as an expression to each waveguide, and performing temperature sweeps. Let's begin by opening the MZI circuit. Click on the blank part of the canvas with the right mouse button, then Edit. This brings up a property editor for the project. Let's add some properties. Click on Add. The name will be temperature. It will be a temperature number. Set it to 25 degrees Celsius. We add this as a category we call thermal. Next, add room temperature. Again, a temperature number. With a value of 25. Next, add temperature coefficient. Which is a number. The coefficient for the silicon waveguide is simulated using numerical mode and is found to be 0.000198467. You can now see the properties for the project includes a section called Thermal. We add the temperature dependence by inserting an element called Straight Waveguide. We put this in series with the first waveguide. We set the length to match the waveguide. We will use an expression for the effective index. This will get added to the effective index of the mode waveguide. The expression is placed in the expression field for the effective index. It is temp coefficient times the difference between the room temperature and the chip temperature. When you change the variable temperature, say to 27 degrees, you can see that the effective index is changed by a small amount, by about 0.0004. We then duplicate this waveguide section and complete the MZI. The length is set to match the second waveguide, which is 300 microns. Next, we run the simulation. We add the gain to the visualizer. We label this as the 27 degree case. We resimulate for a different temperature, say 29 degrees. We add the results to the visualizer. We label this as the 29 degree case. Zooming into a peak, you can see that it has shifted. Next, let's perform a temperature sweep. This is done using the Optimizations and Sweeps window. Add a sweep and edit it. Choose the number of simulation points, say 10. The parameter we want to change is the temperature. You can find it under the root element, and you can see the variable temperature. Define the start and end temperatures, say from 25 to 35 degrees. The result we want is from the network analyzer, namely the gain. We label this as gain. Let's save the circuit. To run the sweep, use the Run button in the sweep window. This will perform the same simulation 10 times. It will save the simulation files to a folder for each parameter. Once complete, we will load the results and plot them. Right-click to open the visualizer and select Gain, which is the result we defined in the sweep. The y-axis is the temperature range from 25 to 35 degrees. The x-axis is the wavelength, and the colors represent the amplitude or the gain. You can see the diagonal lines show that the peaks and dips of the MZI spectrum are shifting with temperature. And this concludes the temperature simulation for the circuit.